So the first one is called ComportexViz, but for NuPIC, by Marcus Lewis. So we're going to watch that video now. Once it's done, Marcus, you can come up to the mic if you want, and we will discuss.
Hey everyone, this is Marcus Lewis, and I'm here to show you a new way of running NuPIC HTMs. And it looks something like this. Now what you see here is a browser front end talking to a server that's running NuPIC. This experience right here, watching a command prompt and a data output, is how people run HTMs today. There's a lot that's good about this, but I think there's also a blind spot. And we start to cover this blind spot with something like this. Now before I show you more, I'll give you some context. This leaves out a few details, but it should work. So this environment, known as ComportexViz, is a way to see an HTM run. It aims to be one of your main tools for making sense of what your HTM is doing. Over time, it's gotten a lot of mileage and a sort of feedback loop of design tweaks. So I'm psyched to bring it to NuPIC. I should mention that you should click this help button. We tried to make this help section good, and parts of this tool definitely have a learning curve. And we're actually okay with that. The tool aims to be useful to people who already know how to use it. So here's a quick overview. Over here you see the input values, and this is them encoded into bits. And this is a HTM layer. Each of these bits in the layer is a column. These input bits and columns are displayed with time as the left-right dimension. So you examine a single model by going up and down, and you examine it across time by going left and right. You can also get rid of the time dimension and display individual models in 2D. And this looks a little different when you run it. You'll notice the columns are different colors. Red means active, blue means predicted, and purple means both active and predicted. When you click a column, it shows the underlying cells with a similar color scheme. Now, I still haven't shown you a single synapse. So let me draw your attention to these synapse boxes over here. You can see that we've not been saving them. For a system like this to be practical, it has to be fast. And it won't be fast if you have to save the entire synapse graph every time step. The way I solved this with NuPIC was by making it easy to toggle synapse saving on and off. And by letting you configure how much gets saved. This is the trick for running HTMs for lots of time steps without totally losing access to synapses. So let's look at them. These are feed-forward synapses from input bits that activated this column. And looking at another one, over here you see the distal synapses to columns in the previous time step. Now, I think this is a mix of cool and still a little bit disorderly. I'm kind of intimidated by these 2048 columns. Here I want to show you something Felix added that I'm not sure I would have thought of, and that's of using creative sorting. This sorting comes in two flavors. The first is to sort the columns by how recently they were activated. And because we're showing time from left to right, you get this sort of staircase shape, where each step down shows the columns that haven't been active since the reference time step. The other approach to sorting is to build your own ordering. Select a time step and say these are first. Select another time step and say these are second, and so on. You could use this, for example, to watch how a single column SDR repeats and varies over time. And now that we've sorted this, the distal synapses are much more orderly. You can see them all here going to columns in the previous time step. They're not flying in every direction, and they're not shooting off out of sight. So I hope I'm illustrating the point that sorting can give you a useful view on an HTM's behavior. And we're nimble about it, jumping from one reference point to another. So, in closing, I'm excited to welcome NuPIC to this party.
Thanks. So, first of all, that's pretty impressive. This is a complex visualization for a very complex problem space. At our last hackathon, I talked to Marcus when he showed another visualization demo that he was working on. The last 2 hackathons we've done visualization demos. And I think I've told him at both of them, if you could do this for NuPIC, that would be amazing. And he has done this for NuPIC, which I think is really impressive. And actually, when he first started it and asking questions about doing this, I think I said, you know, Marcus, this is going to be harder than you think it's going to be. And he said, actually, I've already done it. So thanks, Marcus. That's pretty cool. I wonder if there's any thoughts from our judging panel on this interesting visualization.
Yes.
Marian.
Okay. Can you hear me? Can you hear me now?
Yes.
Okay, great. So first, very nice visualization. And I have a question about, it's a technical question. If I am, for example, using the network API or the OPF, how would I update this so that I could use this visualization? Is it through WebSockets? How do you make NuPIC and ComportexViz communicate?
So, the answer to this question will change quickly over time. Currently, it just assumes a one region, one layer setup, and it just sends over the information about that. So that's just not something I've implemented yet. But right now, you just plug it into a typical OPF model. You just attach it to that, and it does the rest. So you can pretty much you can grab any demo really from the NuPIC experiments and just attach this to it right now, and it'll work.
So I'm just curious how technically you attach it to this.
Yeah.
Do you write to a file?
You hand it a model and a step function. And then from then on, it's just watching the model and saving stuff off as necessary. And your step function just says what to do. So it might be pulling it from a CSV, it might be doing something totally different.
Okay, thank you.
Yeah. Hi.
When I tried training HTMs, one of the problems was not knowing how much data to feed it till it had learned. And you feed it some data and see how well it does, and you feed it some more and see how well it does. Is there a way that this could actually show you the progress of learning? Do you know when you've fed it enough?
Yes. So one thing to point out is that a lot of this work here, I did do a lot of work, but Felix also did a ton of work. And for his implementation of HTM called Comportex, he already has that. It's the time plots. As you watch it run, you sort of see the overall ratio across time of how much was active, how much was predicted, and how much was both active and predicted. So that gives you that visualization. So it's just a matter of porting that over. So at this point, there's a series of things that can be added. This just lighting this up, and that would be one of the early ones that would take a day.
Sounds really useful. Thank you. I'm a big fan of visualization.
Yeah.
Me too.
It seems like this could be a great debugging tool for people. Even if you're working on encoders, you could see really easily if you have a really bad encoding, maybe it doesn't learn as well. It seems like it should be really easy to see that kind of stuff.
I've enjoyed it for that kind of thing. For instance, if I know that something weird happens on step 545, like I may know, you can run it to step 544 and then set a breakpoint and then just go and it's just it's the interface for getting yourself to that step before stepping through the algorithm word.
Very good.
Yeah, I'd just like to follow up on what Subutai was saying. My general question is, what are the use cases and what are the variety of users for this? So
Sure.
There might be one person might be using it for understanding the algorithm in a more visual way. Another person might be doing it to debug.
Yeah. I'd say the initial understanding is a secondary user for this. It's more for the people doing the research, the people applying this with having experience. I would say it's not about learning how it works. It's more about learning how it behaves. How it works you can get from reading about it. You can model it in your mind. But the overall dynamics of the system is something that I think this really excels at.
You're
So-
saying it's to teach you about the dynamics of the system as opposed to debugging a system that's not working well? Or?
It's a mix of both. If it's not working well, you start to diagnose like, hey, is this a combination of these steps are a lot of bursting, these steps are very predicted. But it's also, or is weird behavior happening? It's about testing NuPIC itself and a mix of things.
So the workflow might be something like you set up your system and it's running and you think this isn't quite look right. You go back and you change your parameters and run it again and rinse and repeat.
Yeah. I think it might be useful for me to, so my background on this kind of thing is in testing in general. And I think one useful thing I've learned in testing is that testing is all about seeing things from different angles while it's running, like while it's doing real things. It's seeing the different angles. And it's not so much, so testing isn't automation, that's a whole different topic. But it really like the goal in testing, what you're going for is setting yourself up to see the thing from these different angles. And I'd say this is one of those. That's kind of how I think of it.
Okay.
Cool.
Really nice.
All right, let's give Marcus a big hand. Thank you, Marcus.